Hi, welcome back. In this part 2 of Kalman Filter Intuition video, I'm going to talk about how actually Kalman Filter works in trying to do this filtering. So we were seeing where we had a certain set of past predictions and there are new set of measurements which keeps coming. But how does it actually choose which set of data it has to use to do the new prediction? So it uses something called Kalman Gain. I will explain in the next video what actually Kalman Gain is, and we'll go over all the equations and things. So before that, we want to get this analogy of how actually it does from the example which we are using in the previous video. So let's say it has some set of past predictions, which means that we were getting few datas before and it was trying to make predictions, but eventually it started learning things the same, but it doesn't mean like we are not gonna get any more new measurements. We still keep getting new measurements, but how does it actually decide whether to use an estimate which is completely based on what we already know, or use the new measurement? Or is it like something which is between? So that's what Kalman Gain helps in doing. So based on the uncertainty in new measurement and based on the uncertainty of our past predictions, Kalman filter algorithm kind of creates or shifts the balance on one side or the other. It's not going to be completely based on past prediction or completely based on new measure. So it's going to be a balance. But how this balance is going to be, which one is going to get more weightage, is going to depend on the value of the Kalman Gain. So the Kalman Gain, if say our new measurement is going to be really accurate, the Kalman Gain is going to move more towards this. So it is gonna multiply a value which is gonna directly increase the probability of newly measured value gaining more into the estimate. If in case the new measure wasn't really good and we are having more certainty on our past prediction and the new measure seems to be noisy, so the Kalman Gain tries to put more weight on this side, so that we rely more on our past prediction and less on what we got as a new value. So fundamentally this is what it is like trying to balance between what it already knows and what it is gaining from the new measurement. So this is what we intuitively do as humans, where we tend to be optimistic about the new information and we perceive data as it comes, but we still be skeptic about what we are learning new. So every time we get something which is totally out of our past experience, we would try to really check whether it is something which is noisy or it is against what we already know. So you can say the knowledge or the thing which we are having as some kind of a bias we have, and that actually helps us in really deciding should we really believe everything we see as a new experience or not. So that's the other part. Like sometimes we may think that we kind of know all the part, and so that's the other time when we have to learn from the new experience and we have to change the belief we already have. That's when new measurements gets more weightage. So just to give an example of how things may work, say this is an example which I'm showing where we are trying to track the motion of a vehicle, and this vehicle is mounted with both Lidar and Radar system. So we are getting signals at different point of time of the vehicle's trajectory. So what we are seeing here as a dotted gray line is the actual vehicle path, and the green one is the estimated path using Kalman filter. So we could see already, okay, it's kind of doing a good job of estimating. And how does it actually do is, say, we are getting different measurements, and even if we notice where sometimes when the measurement value which we are getting is totally way off from reality, still Kalman filter manages to do a good job in trying to do this estimate. This is because the way the trajectory has been going gives an intuition to Kalman filter that this is the direction which is most likely for the vehicle to take. And also another important feature of Kalman filter is you could have more than one kind of a sensor as a measuring device, so that even if one of your sensor loses the sensitivity or something wrong with that at that particular moment, the other sensor can help in guiding the algorithm better. And this is what we would say it as sensor fusion, and this is starting to have a lot more use case in terms of self-driving cars, where Lidar and Radar signals are being used to really guide the cars. So maybe in an example, in a real example, this is how the car may see the environment. Because in application of in a self-driving car is to do the localization, which is nothing but where does the car is present in its environment, and even to help in a path planning thing. So maybe just to give another example of why a Kalman filter kind of an algorithm will be really useful. Let's say you're driving using your GPS, you're going inside a tunnel, and sometimes or most likely you will lose the signal to GPS. But the phone has or the GPS device has other sensors which could be used to approximate the kind of location which you are having. So maybe it uses the cellular network triangulation method or other things, but it may not be as accurate as a GPS satellite. But the Kalman filter algorithm, even if it's gonna get some noisy data, and if it has multiple sensors, it could still do a good job in making sure that you don't get lost. So I think that's what I wanted to cover in this part. Maybe I hope this gives some kind of an intuition between how we think about data as we go and how Kalman filter does through its algorithm. So in the next part, I will be getting into the equation of Kalman filter algorithm, and we will briefly go through what each equation is and which parameter is really kind of something which we have to focus about. Yeah, catch you again. Thank you.